So now we've got a piecewise defined function. We want to find some function values. So with a piecewise defined function, it's a little different than the standard ones, right? Because we've got two rules that we use depending on where our input is in the domain. The domain of a piecewise defined function is always right here, and it splits it up nicely for you. These intervals don't overlap, so it's all distinct intervals. So we can do it. If I want to do f of -3, I'm going to use either this or this depending on where -3 is in our domain. So we ask, hey, is -3 less or equal to -5? And no, it's not. We know that -3 is bigger than -5, right? It's to the right on a number line. So we're going to use this rule for -3. So we're going to say f of -3 is -3 squared. We're careful we don't make an error here. Be careful with your grouping symbols, right? We want to put -3 in for x, and this is not being squared, so be careful with that. Sign errors are pretty easy to make. All right, so now we simplify. So we've got -3 square, that is 9, and there's a negative tacked out front, so we have f of -3 is -9, and we're done with that one. All right, now we've got f of -5. So we're going to do the same thing. We just come to the domain and we say, well, is -5 less or equal to -5? And of course it is, so this is the rule we're going to use. So we're going to plop a -5 in here. So we got 5 times -5 minus 5. And we can simplify that as well. So we got 5 times -5, that's -25 minus 5. So this is -30. All right, wonderful. So we do the same thing with the -6 here. We go to our domain and we decide which one of these intervals it's in. So x less than or is -6 less or equal to -5, and it is, right? -6 is strictly less than -5, so this is the rule we're going to use again. So we got 5 times -6 minus 5, and we simplify. So -30 minus 5 would be -35. All right, so we found function values using a piecewise defined function.